Okay, so question 5 was a beast of a question, 13 marks. Just picking out some key information. You've got the fact that it's on a smooth plane, so we don't need to worry about our acceleration of our friction. Sorry, we're going to have our tension. It's going to be pulling that block upwards, and it's going to be slowing that block down. We can see our weight here from that block is acting directly downwards, so that can be split into two components, with this angle in here as theta. And we've got our weight acting on our block B. You can see essentially the reason this is going to move down is because 3g is bigger than the 3g sine theta, because sine theta is 2/7. So for this question, it's just a case of resolving the two different blocks. So parallel to the plane, we're doing F equals ma, so going upwards, so that's tension minus this component of our weight, 3g sine theta, that's going to be equal to ma, 3a. And then if we resolve downwards, because that's our direction of motion, for the block B, this was block A, then we've got this time the 3g minus the t, and then again 3a. Now, because these were both 3a, we could essentially equate them. One or two of you treat this like a whole system, which is technically not the right thing to do, because don't forget that acceleration is a vector, and it's not in the same direction, so they wouldn't be equal. So treating it as two separate particles is definitely the right way to go. Two simultaneous equations, so we just solve them simultaneously. I like to add, so I would just essentially add these two together, actually we want the tension, so we might be better off to subtract. So we'll end up with 2t minus 3g, and sine theta was 2/7, so 3g times by 2/7 plus 3g. Rearrange all that, we get a value out of tension of 18.9. Part B was basically just realising what's happening in this question. So essentially we've got two parts to this motion, and it's that whole thing of like V links to U. So we've got the first bit when it's released, and that's when block B moves down here, and that's going to be a distance of 0.8, and part A is also going to move 0.8, because at that time the string is still keeping the thing as a connected particle. So if we resolve for B in this, we're going to need to find that acceleration. Well, the acceleration is just links to this tension. So if you go back to your previous formulas that just said 3g minus t equals 3a, well then you get an acceleration out of 3.5 to that. The whole thing is released from rest. We're looking for our v, and we know our displacement, is 0.8. So we use v squared equals u squared plus 2as. So v squared is just going to be equal to 0 plus 2 times 3.5 times 0.8. So my v squared is just 5.6. So that v squared becomes the u for the next part. Because what happens after that is essentially this tension disappears. When block B hits the ground, there's nothing, the block B is no longer pulling block A, it's just essentially slowing down. In fact, the only force acting on it is this G sine theta. So we've got block A now, and we've got its only force is going backwards, and that's G sine theta. If my force is G sine theta and my mass is 3, then I can rearrange to find my acceleration, and I'll end up with G sine theta over 3, and then now I just need to find how much distance it travels, so I'm doing another SUVAT, but this time I'm using my U, that was my V from the previous part, so the final velocity up here becomes my initial, so my U becomes square root of 5.6, and my S is what I'm looking for this time, and my I'm looking for when it hits rest now, my acceleration is going to be g sine theta over 3. And I do another v squared equals u squared plus 2as, which gives me an s out of essentially 1. And then I need to remember that it travelled the 0.8 as well. So my final answer is 1 plus 0.8, which is 1.8 metres. Hope that helps.